Hi everyone. Let's continue confirmatory factor analysis. I have already done in structure question modeling part 1, part 2. In part 2, we have already run confirmatory factor analysis. Only interpretation is left out. I have continued the same interpretation, same file I have to continue in this video. So I'm sure till the time I'm in structure in the part 1 and part 2 is comfortable to you. If there is any questions, you can ask me in my comment section. And this is, you could see here, this is my finally accepted model. Because in structure question modeling, you have this easily, you can test it so many models where your results are coming best. So then this model would be accepted. So, and all these models you can report in your research paper also, these number of the models, and all the values are here. That is why I had opted this model, model 1, model 2, model 3, model 4, model 5. So let's say you have taken this fourth model is accepted. So you could say, I mean, that you can justify this, why you can compare this model with other models, those you had created, and why you had discarded other models, why you had accepted this model on the basis of these values, and this model is best fit. Why? This is my final model, you could see here, and this is the mediation effect I had given in this model. This is the government policies. These are the, as a mediation factor is here, and this finally I had accepted this model. Let's continue this one is the CFA. We have already run this file. You understand how we have to run this file, how we will get these values, unstandardized estimates as well as standardized estimates. You could see here, we can little bit bigger this size. Right. And standardized estimates, you could see here 0.77, 0.89, all these values are below 1, right? These are in between -1 to +1. These are my values, and these are my unstandard estimates. You know very well how we have to run this file. From this place, you have to choose your file, which file you would like to run in AMOS, right? And here is, okay, I would, and again, here is, you will choose all these parameters. In the output, you will choose minimizing history, standardized estimates, indirect and direct, and total effect. And in estimation, maximum likelihood, because this is functioning on the maximum likelihoods, and you have to choose this thing. Then after that, you will run this file. A moment you will run this file, this button, this icon would be red. That means your file is complete. I mean, interpretation, I mean, output has come. That shows. That means there is no problem, no error in your file during when you are running this file. Then you could see here, chi-square test is 189.2 degree of freedom, etc. So now we will click on this thing. We will click on our output file. And output file is here. Mine output file is here. So one by one, we have to discuss. I had already explained you analysis summary when I have run on 14 July 2021. I mean, this is the time when I have run this file. And after that, notes for groups. This model is recursive. Sample size is 371. As I have shown you, this 371 total respondents, right? I have collected data, 371 respondents data. And on which scale I have taken, I had already explained you here. This is after this questionnaire in the earlier video, construct and measurement items. I have taken all these statements, and this data has been collected at the 1 to 7 Likert scale. 1 is strongly disagree, 7 is strongly agree. And you should always taken like this, because number of the research papers I have seen, people have taken 1 as a strongly agree and 7 as a strongly disagree, and this is incorrect. Why? Because the number of the researchers, they had already proven in their research 7 is strongly disagree, because highest number we are giving to the highest number, to the highest number, and lower number we are giving to the poor values, strongly disagree. Right. So next we come to this output. So sample size is 371, right? And variable summary, I had already explained you. Observe endogenous variables, right? Endogenous variables means those are my this thing you can see on which we are depend. You could see here, these are, where is the arrow is going inside, right? Environment, government policies, all these things, these are unobserved variables. Because if somebody will ask you, you would like to measure satisfaction, so satisfaction you cannot measure at a scale. That would be supported by some statements. Through this only I can observe satisfaction. So that is why we are calling it, suppose I am talking about environment, I'm talking about perception about the electric vehicle. I cannot measure directly, because through the supporting these three statements only I can observe perception about the electric vehicle. So this one is the unobserved variables. That is why we are calling it unobserved variables, because they dependent on this, because these things are dependent on these variables, right? So this is my this is the observed endogenous variable, unobserved exogenous variables. And in the exogenous variables, you could see here in the exogenous variable, these are the error terms. These are also unobserved variables. Then variable counts, I had already explained you, 35 is total in my model number of the variables. Observed variables are 15, unobserved variables 20, exogenous variables 20, endogenous variables 15. Now we come to the parameter summary. So now you could see here, fixed are 20, label 0, unlabeled 10, and variances are 20, and total are, these things are 30, where we had given weights. How come we can measure? These are total number are 20. Then you could see here in my figure, right? When we come to this point, you could see here, these are you could see here, here is the all the error terms, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, total 15, and one weight is here, 1 2 3 4 5. So total are fixed are 20. This number is came from this place. Unlabeled are 10. How come it would be unlabeled are 10? Then we can count it, 1 2 3 4 5. Where is the no I mean no one is the weight we had not given, 1 2 3 4 5 6 7 8 9 10, right? So these are the unlabeled, right? These are the unlabeled, right? And variance are there is the 20 and total is 40. You could see here variance we talk about, these are because what is the correlation in between these factors with this factor with this factor, these are the all are covariances. Next we come to the, so you understand, because we are unlabeled, we have to find out. So total is 60. When we come to the notes for model, you could see here, number of the distinct sample moments 120, number of distinct parameters to be estimated 40, degree of freedom is 80, means 120 minus 40, that is 80. Minimum was achieved chi-square test in my this case, in this sample size. You could see chi-square is 189.190, degree of freedom 80. So probability level is 0.00. It should not be significant, right? But in my case, it is below 0.05, but it should be above 0.05. It should not be. I will tell you why it should be. So I would explain you this reason also, why it should be. You could see here, I had copied this model as it is. You could see here, chi-square value should not be significant. Why it should not be? Chi-square value should not be significant if there is a good model fit. Because why? Higher the chi-square value, chi-square, the more the difference between the model estimated and actual covariance metrics, so model fit is worse. So it should not be significant. And chi-square value divided by the degree of freedom should be around 2 or 2.5. Let's check. Right? We come to the next table, estimates. So when we come to the estimates, notes for the model, right? After that estimates, I will tell you from where is 2.5, where we have to check in model fit in this, right? So let's come to this estimate. Estimate is, you could see here, EC3 to environment, EC2 to environment, right? In relationship between regression weights are there, right? And wherever you find any difficulty, you will just click on this, right? So this, the complete description will be there. For each estimate, one or more the following items are displayed. Estimates means what? Standard error, how we have to calculate. CR, critical ratio. What is this critical ratio? So critical ratio is the parameter estimate divided by the estimate of its standard error, right? So this is the complete description is here if you will found any difficulty. Now you could see here CR, how we have find this CR. We will click on this, then you could see is Z equals to 1.27. This one is divided by this standard error. Then we will find these values 13.384, 1.27, right? So we can see here, right? We can divide, let's say 1 point, we can say 277, right? Divided by 0.095, 0.095. So have we got the same value? Yes, of course. 13.384. I mean, it's a little bit because this is the calculated by the this system, whatever the programming has done. So this is the nearby almost same value. Then we come to the same is the same way. We have to get this CR value. CR value is nothing like it. It's like a T value, right? Then we come to the standardized regression, right? Standardized regression weights, right? That is also same 0.691. So can we check this thing whether in our diagram that is same? We can check it. Standardized estimates. We will run this thing, right? Standardized estimates. Yes, we can check it. What are our values? EC3 to environment 0.691. Can we check it? 0.6, yeah, same. Environment to EC3, right? What is the correlation? 0.69. Then we can check another one. 0.885 environment to EC2, right? Can we check environment to EC2? 0.89. Yes, absolutely is here. 0.77, right? That is, I'm sure you understand this table. What are these values? These are the standardized regression weights, right? And you will click again, right? Whatever, if you would like to see, what is this? This is the correlation values basically. Then we come to the covariance. So there is how many covariances? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10. And you could see here in our previous notes when I will talk about this thing, this is the, yes, unlabeled 10, right? These are this is the covariances also, right? So covariances value, can we check this thing, right? These are the covariances values, right? So correlation kitna hai? I mean 0.443, 0.617, all these things. So can we check it here? What is this? One we have to take it. This one is the environment to government policies 0.443. This one is the environment to 0.443. This is the same. You could see here 0.44 is the same values, right? And further is 0.617. This one is the perceived economic benefit, and in between two government policies. So can we check in my diagram government policy and perceived economic? Yes, same 0.62. So you understand, I mean, from where we have got these values, right? And variances, right? That is also the same way you can calculate estimates divided by standard error. Then we will get these values. Total effects. Now we come to the standardized. Yes, of course, these are here. And as well as if we talk about standardized direct effects and all, right? Then we come to the this one is the minimization history, right? Minimization history. And before that, I would like to show you what is this model fit. This is the most important part in static equation modeling, how you have to interpret these values. That's the most important thing, right? How we have to interpret these values. So one by one, let me explain you, right? Semen, Semen is, what is this? This is nothing is like, this is your chi-square value, right? Chi-square, you could see here, this one is the, in this notes for groups, answer variable summary. Yes, 189. Chi-square value is 189.90, and you could see here that is in the model fit, that is also same, 189.90, and degree of freedom 80. When we will divide Seaman divided by degree of freedom, this value is here 2.367, right? So I will show you, I will copy this table in my, here only. So Control V. You could see here, this is my value. This is my value, and chi-square, I had already said this statement, chi-square value divided by degree of freedom should be around 2 or 2.5, and exactly my value is also falling in the same way. I mean, Seaman chi-square value, it should be on the lower side, right? This would be lower side, and it should not be significant. Then your model is good. Your model is good. It is acceptable. Right. So interpretation is very, very important. When we come to this RMR, right, GFI is also should be more than 0.9 or 0.95, right? GFI also should be more than 0.9, right? And bat fit, if we talk about all these things, we will discuss in my Word document. When we talk about the bat fit, RMCA, this one is RMSEA. This value should be less than 0.06. My is the border case, right? If we will like to, suppose you would like to improve these values, so you have to collect more data. So if the sample size would be bigger, your values would be good. So right, if you would like to improve these values, you have to collect more data, add on some more data, right? I am on the borderline 0.06. So one by one, this one is the, you could see parsimony adjusted measures, right? What it should be, there's the 0.72, it should be closer to 9. And NFI, RFIA, IFI, TLI, what is this? AGFI, GFI, PGFI, RMR, what are these? Seaman, BF, already, I had already explained you. So now one by one, let me discuss all these things. Right. So in the, yes, the most important, this is the independence model. This is the independence model, right? So independence model is the, what is this independence model? Independence model is the null model, which means model in which variables are assumed to be uncorrelated with the dependence. So we are basically comparing this default model with the independent model. So next we come to the CFI, right? What I had already explained you, what is CFI, right? CFI is also known as Ventler Comparative Fit Index also. Here is CFI, it should be close to 1. That indicates it is a very good fit model. CFI should be equal to or greater than 0.90 is also to accept the model. If your values are nearby this, that is also. It means, what is the meaning of this statement? It means 90% of the covariation in the data can be reproduced by the model. Right? 90% of the covariation in the data can be reproduced by the model. Next is IFI, that we are calling it delta 2 also. I can show you in my output file. IFI, where is IFI? Yes, this is IFI. IFI, you can see here in the small font size, that is delta 2. So we can call it, what is the meaning of this 0.967, right? So delta 2, in the structure question modeling, again, I would say interpretation is very, very important, because why we are running, whether our model is accepted or not, and statistically you people are showing this, our model is accepted, our model is good fit. Until or unless these values are not coming up in a good shape, I mean, what is the acceptance rate? So you have to discard your model. So, and behind this, there is some theory, right? I said, I will explain you what is my theory behind this and how come I have to reach my final model. So incremental fit index, we can call it IFI, or we can call it delta 2. IFI should be equal to or greater than 0.90 to accept model fit. And in my case, you could see here, this is the value. We can copy this thing also, right? We can take it, we can carry forward this thing, right? Copy. and I will paste it here. So I mean that could be more clarity to you. Control V. So now all the values are here. So again and again we can see here. This one is the delta 2, right? Delta 2. I'm talking about IFI, and IFI should be equal to or greater than 0.90 is acceptable. But my values are very good. 0.967. So that is acceptable. IFI can be greater than 1 under certain circumstances. It could be. There will be. It can be 1 also. Now, I will explain you in detail in the next video. Each and everything I would explain you how we have to calculate CFI, how we have to calculate other things. So next we come to the normal fit index, NFI. NFI we have taken is this is delta 1, right? Am I right? This is delta 1. So what it should be? It should be also, here is note down, it's an alternative to CFI. It varies from 0 to 1. 1 means perfect fit. Again, it is nearby 1. So in my case, values are 0.945. So it should be 1 means perfect fit. And NFI shows the proportion by which the researcher's model improves fit compared to null model. So in my case, let's say, this is the independence model, right? This is the null model, right? So it shows the NFI shows the proportion by which the researcher's model improves fit. Next, we come to the this one is the some researchers accept cutoff is 0.80 also, but I believe it should be more than 0.90. Next, we come to the Tucker's-Lewis index, right? Tucker's-Lewis index, you could see here, this is my TLI. We can call it TLI. TLI. Right. It should be, again, it should be greater than 0.9, right? Or 0.95. So Tucker's-Lewis index, TLI or RHO2, right? RHO2. So it should be close to 1, indicates good fit. Then relative fit index, RFI or RHO2, you could see here. This one is the RFI. I'm sorry, I had written RHO2. TLI is RHO2. Let me correct it. This one is the RHO2, right? And this one is the RHO1, not 2, 1. Right. So relative fit index, RFI, right? RFI, it should be close to 1, shows good model fit. You can report in your research paper, any one of them. How come you are saying your model is good fit? Any of the values you can show there, and you can explain in your content, in your writing part, our values are the greater than 1. That is why I'm staying. My model fit is good. Next, right, this one is the GFI, right? GFI, good fit of the model. GFI, we can see here in my output file. Here is the GFI. I could right. Okay, fine. Next, we come to in my Word document, rather than this part, we can come to the AGFI. AGFI is also, it would be the, GFI and AGFI. I will again copy this thing, right? I will copy about this tool B. Now it would be more clarity to you, right? So here is in my model, this is my GFI. This is my GFI. This is my AGFI. So this one is the GFI stands for goodness of fit index, GFI. It varies from 0 to 1, right? Okay, fine. A large sample size increase GFI towards the positive direction. If the sample size, it would be larger, so definitely your GFI will increase in the positive direction. That means towards the good fit side. And GFI cannot be interpreted as percent of error explained. Right. And GFI shows error in reproducing the variance covariance matrix like R square. What is the role of the R square in regression? That the same way that is the role of this GFI. And GFI, it should be greater than or equal to 0.90 to accept this model. And that is also reflecting here. In my case, value is greater than 0.90. When we come to the AGFI, that means adjusted good fit of the fit index. You remember in the regression, adjusted R square, right? That is also the same thing. right? 0.9. And always you remember in regression, R square value always higher than adjusted R square, or we can say adjusted R square value is always lesser than R square value, right? Same is reflecting here. GFI and AGFI, same relationship is there. Adjusted goodness of fit index, AGFI, and how you can interpret through this, right? Actually, structure question modeling is nothing. It is a way of reflecting regression, basically, but in AMOS software. So it uses means square instead of total sum of the squares in the numerator, and denominator varies from 0 to 1. AGFI 1 greater than 1 said it's just identified model with almost perfect fit. It's closer to 1, right? And AGFI less than 0 model with extremely poor. That means your data sample is very small if it is less than 0. And AGFI can be at least 0.90. And in my case, my value is 0.90. It should be more than that. My values are lesser, and here is also GFI. It should be more than 0.95. But in my case, this one is the respondents data. This thing is a little bit below, and that is on the border 0.90. So, but in your case, it should be more than that. Then we come to the root mean square residual, RMS residual, or we can call it RMSR or RMR. If RMR is near to 0, then we can say better fit model. You can say, so we can call it, it is the bad fit model and bad fit. Right, these are the good fit. Good fit always closer to 1. You always remember. Good fit is always closer to 1, and bad fit always nearby 0, right? And standard root mean square residual, right? SRMR, right? That is smaller the standardized RMR, then better the model fit, right? SMR is the average difference between the predicted and observed variance and covariance in the model based on the standardized residuals. Let me see my output. Can we see RMCA, right? And we can see RMR, right? And it is RMR. You could see it is nearby, closer towards the 0.069, right? That means your model is good fit. I mean, through bad fit, you are saying model is good. So it should be near to 0. It should be closer to 1. Then we come to the what else, right? And we come to the this one is the standardized residual, and SRMR is 0 when model is fit is perfect, right? When we come to the parsimony normed fit index and PNFI, it is close to 9. Let me check in my model. Parsimony, yeah, we can copy it and paste in my Word document. That could be right. Parsimony adjusted measures PNFI, right? I am talking about PNFI 0.720 in my case, and it should be close to 9, right? So that means your model is good. Your model is good. So this is all about your this one's confirmatory factor analysis interpretation. That's the most important. And in the next video, I am going to explain you, this is my model, what I am assuming. It is based on theory. It is based on some theory, because how come all these, this is the perception of the electric vehicle is based on all these 3 things. And then after that, we want to check, right, what is the behavior intention of the customer, right? So we have to check this model, right? Path analysis, we will do it, or structure question modeling, we have to do path analysis. We will do it in the next video, right? So I'm sure this would be helpful to you. That would be, I'm sure on your respondents data, you can analyze in the same way. And see you in the next video. Definitely, we have to get some more good results.